We're now going to look at adding and subtracting harder fractions. This is going to be fractions that do not have the same denominator. Okay, so we're going to look at these three examples. Now the first one is straightforward enough. We have 1/3 plus 2/3. Now if we're given this question, first thing when we're adding and subtracting is always look for what is the denominators. Are they the same or are they different? In this case they are the same, so this is actually just a simple example to start us off to remind us that when we have the same denominator, then we can just combine it into 1 and add the top line there, 1 plus 2, so that's 3 over 3. Now 3 over 3, that is a fraction that can be simplified. Anytime we have a number on the top that is the same as the bottom, that means there is one whole, one out of 1, which is one whole. Okay, but focus on the fact that because they were the same denominator, we were able to just add them straight away. Now example B, we have 1/3 plus 2/6. Now we cannot add these yet because they do not have the same denominator. So I'm going to need to do something in order to get two fractions here that have the same denominators. Now I hopefully remember from equivalent fractions that I can multiply the top and bottom of a fraction to form an equivalent fraction, and it doesn't change the value of it, right? But it will change the numbers. It will change the numerator and change the denominator. So this is my task here. I actually need to form an equivalent fraction of this first one in order to make the denominator of 3 match with this denominator of a 6 so that I can add them. So it's hopefully fairly easy to see that if I were to multiply this by 2, that's going to turn into a 6, which is going to match up with this. But remember, when we form an equivalent fraction, we have to do the same to the top and the bottom in order to keep it the same value. So write down what your equivalent fraction now is. It's 1 times 2 is 2, over 3 times 2 is 6. That now becomes 2/6 plus 2/6. And now I have two fractions with the same denominator, therefore I can combine them into 1. 2 plus 2 is 4/6. I'm not done because these are both even numbers, which means they're definitely divisible by 2. So I need to simplify them before I'm absolutely finished. So 4 over 6 becomes 2 over 3. Final answer. Okay, now look at this next example. We again are starting with 1/3. This time we are adding 2/7. Now, in the last example, we were able to form an equivalent fraction which turned 1/3 into 2/6 and made these denominators match up. But we run into a problem in part C. The problem is there's no whole number that I can multiply 3 by in order to get to 7. 7 isn't in the 3 times table. So I actually need to figure out a number that 3 and 7 will both go into. I actually need to figure out the lowest common multiple of both 3 and 7, and then I need to change both of these fractions into equivalent fractions with that number at the bottom. So I have to figure out, in this case, what is the lowest common multiple of 3 and 7? What is the next number that they will both go into so that I can get these denominators to match? Well, I can think of my 3 times table, and I can maybe do that at the side. 3, 6, 9, 12, 15, 18, 21, 24. And I can think of my 7 times table. 7, 14, 21, 28. Now, hold on, I do have a number that appears in both lists. It is going to be a common multiple, therefore a common denominator, and it is going to be this 21. So actually I can form equivalent fractions here with 21 as the denominator for each fraction, and that's going to let me add them. So you need to figure out, first of all, what would I need to multiply 3 by to get to 21? Well, I would need to multiply that by 7. So I'm going to have to do that on the top as well. And what would I multiply 3 by to get to 21? That would have to be 3. So you need to times the top and bottom by 3. So you're forming two equivalent fractions, which now, after that bit of work, should have this denominator that matches. So 7 times 1 is 7, 3 times 7, 21, 7 over 21, plus 3 times 2 is 6, plus 7 times 3 is 21. So the reason I had to do that is so that I was able to produce these two fractions that now have the same denominator, so now I can add them together into 1. 7 plus 6 is 13 over 21. Now just double check, can I simplify that? Well, no, 13 is a prime number. It's not divisible by anything other than itself and 1.